Hello everyone, welcome to our another video, and this video is about matrices, and here we are going to talk about square matrices. When I talk about the word square matrices, then by square matrices I mean that number of rows is equal to number of columns in a matrix. Okay, just think about a matrix that is a square matrix. Here is one example. So you see that there are 2 rows and 2 columns, right? So that is the matrix, that is the example of square matrix. And because the number of rows and column are same, and let's suppose I call it n, so sometimes we also call the matrix of order n. So I can call this matrix of order 2 because number of rows and columns are 2. Okay, another thing is about matrix multiplication. So when we multiply 2 matrices, if they are able to be multiplied, then it's not necessary that A multiplied by B and B multiplied by A, they produce the same result. It's not necessary. Even if they are square matrices of same order, it's not necessary. That means for all matrices, the commutative law is not guaranteed. But if I talk about inverse, so that is the first thing that is true. That means commutative law. So let's go to the definition of inverse matrices. Inverse of square matrices. So suppose I have a matrix of order n, that is a square matrix, then a matrix B of the same order will be called inverse of A if they satisfy this property. Okay, so one thing is about the commutativity. Another thing is that they, when are multiplied together, they will give identity matrix. This I represent for identity, and if you don't know about the identity matrix, then that's the matrix having all the entries on the diagonals 1 and non-diagonals zeros. So that is the example of a 3 by 3 identity matrix. So in that case, if that is true, I will say that B is inverse of A, and that is again equally true that A is inverse of B. Okay, but never confuse this A inverse with 1 over A, right? That because there is nothing like matrix division. So however, the formula for inverse of the matrix is given by 1 divided by determinant of A multiplied by adjoint of A, which is again a matrix itself. And how we find that, I am going to explain with a very basic way, a 2 by 2 matrix. I will explain the whole process to find the inverse of the matrix. But one more thing I want to mention here, that if you want to find out the general method to find out adjoint of A, then you can check out my another video in which I have explained how you get the adjoint of A in a general way. Okay, let's begin, and let's begin with this 2 by 2 matrix. Okay, now I want to find inverse. What do I need? I need determinant of A and adjoint of A. Okay, how to find out determinant? You know that that's kind of cross multiplication, keeping the minus sign in between in mind. Don't mess up with the minus signs. 3 times 2, just put the minus. If there is another minus, don't forget to put the bracket on. 1 times 2. This way your answer can never be wrong. So 6 minus minus 2. Okay, that comes out to be 6 plus 2 actually, that is 8. So we got our determinant, which is 8. Okay, the next thing is to find out the adjoint. Now in the 2 by 2 matrices, finding adjoint is not a problem. That is an easy process. Okay, so I'm going to explain here. So for this matrix, you will just switch the diagonal entries and change the sign of the non-diagonal ones. What I mean to say, just switch the diagonals and change the sign of other 2 entries. Okay, And here we go with the inverse of the matrix. According to formula, that is 1 over determinant of A. That means 1 over 8. Okay, and the adjoint. Okay, you know when a number is multiplied, that means this number will be multiplied by each and every element of the matrix. Okay, now here is a task for you. Go and verify if it is true or not. So A inverse was this, and when it is multiplied by the matrix, do you get this identity matrix? So that is a task for you. Check it out and let me know, did you get it or not? Okay, till then, bye, take care and enjoy your math learning.